Before we can graph using slope-intercept form, we need to talk about both slope and intercept. And we already have talked about intercept, so today we're going to be talking about slope. On your notes page, you'll see that the very first thing on there is the definition of the word slope. And the slope of a line is how steep that line is. And it's generally written as a fraction. You will see sometimes where it's written as a whole number, but we know that we can turn a whole number into a fraction very easily by putting the number 1 underneath it. And when we look at a graph, I'm going to ask you to read the graph, and that means to tell me if it is a positive line or a negative line, and we'll read slope the same way that we read words in a book or on the screen that you're reading right now. And we read from left to right, and so that's how we're going to be reading graphs, is from left to right. There are 4 different types of slope, which is why you'll see that I have 4 graphs here. They could be positive sloped graphs, negative sloped graphs, and then we have 2 special graphs that I'm going to go ahead and highlight. These 2 special graphs, and you'll see what those look like in just a moment, have 0 as a slope. The slope is 0. Remember, 0 is a number, so I'm not saying that there isn't a slope. I'm saying that the slope equals 0, the number 0. And the last one is a graph whose slope is undefined. So let's go ahead and graph this first one. It's going to be a positive graph, and this is how we draw a positive graph. It doesn't matter where the graph begins as long as it is going up from left to right. So I've just drawn a quick graph. I'm going to check this the way I'm going to ask you guys to check this in class. So you'll put your finger on the left of the line and you'll slide. Did your hand move up? Yes, it did. That means I know that this is a positive graph. I could also draw a positive graph like this. Now, why might a student think that this graph that I've just drawn right here, why might a student think that this is a negative graph? I want you to have an answer to that tomorrow when I see you in class. But I want to know why somebody might think that this is that this graph that's positive. Here's how I can check it. I'm going to take my hand, put my finger on the left, slide, my finger moved up. That's definitely a positive graph. But why might a student think that this graph down here is negative? Now let's look at what a negative graph would look like. A negative graph, doesn't matter where it starts over here on the left, but a negative graph is going to go down. This is a negative graph. And I'll check that. I'm reading the graph, I'm reading the slope. I'm going to take my hand, I'm going to put my finger on the left and slide. My hand moved down. That tells me this is a negative graph that I've just drawn. Let me go ahead and draw another negative line on this same one. Like that. That's a really steep graph. Let me check. Put my finger on the left, slide. Yep, my finger moved down, so that's definitely a negative graph. So now we've got these 2 that I highlighted at the beginning, where we have slope is 0 and slope is undefined. And these 2 graphs are special cases. We've already talked about them in a previous lesson. These are graphs that are either horizontal or vertical. This graph of a horizontal line has a slope equal to 0. If I go back up here to my definition, the definition of slope is how steep a line is. Well, if I have a straight, flat line, like the ground or like the table in front of you, how steep is it? It's not steep. Okay, it's not. It doesn't have a slope. It's not going up and it's not going down. It doesn't have a steepness. That's why the slope is 0. And this final type of graph, well, since we've already done horizontal, you can probably figure out that this will be a vertical graph. And this slope is undefined. Undefined, I want you to think of as if these were mountains, okay? Um, undefined kind of means the same thing as not possible. It's not possible for me to climb the wall that's vertical like this, that's straight up and down 90 degrees. I wouldn't be able to climb up a cliff that was straight up 90 degrees without some special equipment. So this is called undefined slope. And in a moment, when we talk about the definition of slope using math words and math vocabulary, we'll see why this is undefined. So here's the formula for slope, and I've actually written it 3 different times. The one I want you to highlight, the one that you will hear me saying over and over again, I will ask you, slope is what 3 words? And what I would like you to know and what I'd like you to be able to respond, slope is what 3 words? Here's the 3 words: rise, over, run. We mentioned earlier in this video that slope is a fraction, and this is the fraction that I'm talking about. You can see that all 3 of these definitions have a fraction line because our slope will be a fraction. But if I ask you, slope is what 3 words? These are the 3 words I'm talking about: rise, over, run. This second definition is going to help us with this problem down here. Now this problem is giving me 2 points. Here's 1 point, and here's the second point. Both of these points create one straight line. And I can use this formula right up here to figure out the slope between these 2 points. Now, this formula looks really scary. It's got this subscript 2, subscript 1, y2 minus y1 divided by x2 minus x1. It really looks kind of scary, but it's pretty easy to use. Here's what we're going to do. It's going to be a fraction line. Like we said, slope is a fraction. And the subtraction sign on the top and bottom, all right, that's pretty easy. So now all I need to do is figure out, okay, the y's are going on the top. And I've written a little rhyme over here that will hopefully help you remember that the rise are the y's. Okay, the rise is the y's. It's going to be really tempting as a student to want to put the x's on top, because in our alphabet, x comes before y. But that doesn't work for our formula. Rise is the y's, because I'm talking about the vertical change, which are the y's, and the horizontal change, which are the x's. That's my third definition over here. Vertical change, which are the y's, horizontal change, which are the x's. So let me come down here to these points and show you how easy this is. Which one of these numbers is the y? This one, because it's always the second one. So I'm going to go ahead and put that in on the top. Which one of these 2 numbers is the y? This one, because it's always second. It goes x, then y. Now let's go back and do the same thing with the x's, because I know that the x's go on the bottom. So I'll put this x first, and I'll put this x second. Now all I have to do is subtract the top, subtract the bottom. -4 take away 2 is -6. -3 take away 5 is -8. On a test, you know this answer would not be good enough for me. You would need to go one step further and simplify it. Negative and a negative is going to give me a positive answer, so I'm going to rewrite my answer with positives only. And I can simplify 6 and 8 by dividing the top and bottom by 2, which will give me 3/4. The slope of the line between these 2 points is going to be 3/4. Let's go ahead and check that on a graph. I'm going to begin by putting these 2 points on my graph. -3, -4. Begin at the origin, move left 3, and down 4. There's my first point. And my second point, 5, 2, begin at the origin, move right 5, 1, 2, 3, 4, 5, and up 2. Now I'm going to sketch a line in between here. It's not going to be very straight, I'll warn you. But the idea is that there's a straight line that goes between these 2 points, and I want to figure out the slope. If I had my little pointer and I put my finger on the left and moved to the right, I see that my slope is going up. I know that this slope is going to be positive. Now I'm going to count, I'm going to draw. How far did I move up to get from this point to this point? And how far did I move over to get from this point to this point? Well, let's go ahead and count. I moved up 1, 2, 3, 4, 5, 6 times. And I moved to the right 1, 2, 3, 4, 5, 6, 7, 8 times. And my fraction is slope, rise, over, run. Which of these numbers shows me rising? 6. So the 6 goes on the top. Rise, over, run. The 8 is the run. That's how far I've gone from side to side. And again, I would never leave this slope like this. I would reduce it, not reduce it, I would simplify it to 3 over 4. Let me prove to you that that also works. If I go from this point and move up 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Look at that. I ended up on another point that was right on that line. I could then move up 3 again, 1, 2, 3, and move to the right, 1, 2, 3, 4. So I've proven that my slope is 3 over 4. It could also be 6 over 8, or it could be any fraction that is equivalent. What if I doubled this again? My slope could also be 12 over 16. But in most cases, you're going to want the most simplified answer. Now I'm giving you a line, and I'm asking you to find the slope. The first thing I'm going to do is I'm going to take my finger, put it on the left. Oops, just lost my graph there. It's my finger, put it on the left, slide. I notice that my hand is going up, which lets me know that this graph is going to be positive. I will have a positive fraction. Now I need to choose 2 points. I'm going to choose this point here that's right on a cross, and this point right here is right on a cross. I could have also chosen this one, or this one, or this one. All of these points that I'm highlighting in yellow are right on a place where 2 blue lines cross. And now all I need to do is draw that same triangle. How much did I move up, and how much did I move over? I moved up 3, and I moved over 2. Remember that slope is rise over run. Which of these numbers is a rise? 3. Which of these numbers is the run? 2. Now what if I hadn't picked those points? What if I had decided I wanted to use this point and this point? Let's see what would happen. 1, 2, 3, 4, 5, 6. I rose 6, and I ran 1, 2, 3, 4. I think the slope is 6 over 4. Well, 6 over 4, when it is simplified, becomes 3 over 2. No matter which 2 points you choose on this line, you will find that the slope of this line is 3 over 2. One final graph for us to practice on. I'm going to begin by deciding if my line is positive or negative. I start at the left, move to the right. I notice that my hand is moving down. That tells me that this is a negative graph. That means my answer for slope is going to have a negative symbol in it. You can have the negative in front of the fraction. You could have the negative on the top of the fraction, or you could have the negative on the bottom. All three of these are acceptable ways to write a negative slope. I'm going to choose 2 points that are directly on corners. There's one there, and there's one there. And now I need to count how much did I rise and how much did I run. I'd like you to finish this graph on your own.